Hello and welcome everyone in another episode of Researcher Celebrity. Today we have honor of having Professor Indra Vythilingam with us as our Researcher Celebrity. A brief introduction about ma'am's background. She has done her bachelor's in zoology from University of Madras and then moved to New Zealand and attended Victoria University of Wellington and pursued specialization in entomology, and then for PhD, she moved to University Malaya and did her work in entomology again, where she is now working as a professor at University Malaya. With this brief introduction, I would like to thank ma'am and welcome at the platform.
Thank you.
So we always start this conversation with a question that how and when you decided that you want to become a researcher?
I don't know. I suppose when I was doing my bachelor's degree, I decided that I must do a PhD.
Oh, wow.
So after my master's degree, I actually was like looking up for a job. And someone told me that it would be good if I register for a PhD because while waiting, at least I can start working on a PhD. So that's what I did. And fortunately, when I had finished all my fieldwork in my PhD, I got a job with the Ministry of Health. So I was posted as one of the pioneer entomologists to one of the states in Malaysia, in Selangor State in Malaysia. And then, of course, I did part-time. I did finish my PhD. And I was the entomologist for the state. I was mainly dealing with dengue because at that time in the late 70s, dengue was a huge problem. So we were actually taken in to try to control dengue. So that was my main thing. Because my PhD and my master's were mainly on soil microarthropods. I was not working on mosquitoes. I was working on soil microarthropods, but then I got my job as an entomologist, as a researcher. And while I was working in the state of Selangor, I was very fortunate to have got a WHO fellowship to see what is happening in the USA. So I was able to see what kind of research was going on there. And so when I came back, I started to do operational research, how we can do better to control the vectors of dengue. And in the meantime, of course, I also completed my PhD. I graduated with my PhD. And so the Director General of the Ministry of Health felt that I should move to a research organization and not remain with a control program. So that is how I moved to the Institute of Medical Research in 1990. So from there began my research career on mosquitoes. I started off with Japanese encephalitis, vectors of Japanese encephalitis. Then I went on to work on malaria vectors. Dengue at that time was not my main trust because there were so many other people working on dengue. And, people don't like very much to go into and work with malaria vectors because you have to go into the rural areas. It's not so easy as dengue, you go to the urban areas and there you are. So I started working. And one of my colleagues, she left, she resigned from the institute. So I was like filled in her gap as well. So that's when I started working more and more on malaria. And I had the opportunity also to do research in the neighboring countries in the Mekong region. I had a chance to work in Lao PDR. So I did a lot of malaria work there. In fact, I found the vector for them in that country. And from there, I moved. And just before my retirement with the institute, I was sent to the parasitology department. They thought that I should go to parasitology. So fortunately, I went to parasitology because at that time in 2004, 2005 was when they found that simian malaria, Plasmodium knowlesi, was discovered that it was becoming a huge problem. Unlike in the 60s where they only found one case, here they found a few hundred cases of knowlesi. So everybody used to ask, what's the vector? What's the vector? And so I feel that I was fortunate. I was in parasitology because I was able to work on the vectors as well as on the parasites. So it was a good thing working on it because looking back in the 60s, how they did their work, I think I always feel that they did much more then than we are doing now. I mean, that's the thing I always have. Though, of course, along the line, we have done a lot of work, and but we still have not found a control method yet. That is something that we need to tackle. So because at that time, retirement age in Malaysia was 56. So when I retired from the IMR, I still worked 2 years with them. And then Singapore called me. The National Environment Agency in Singapore called me. So I went there because they were also worried about Malaysia malaria. But of course, dengue was their predominant field. In Singapore, dengue being urban, and dengue was. So, of course, the time I focused more on dengue. And that's where I got very much involved in dengue. And one good thing was that, at least in Singapore, we were the first to introduce that the NS1 kit can be used to detect the dengue virus in the mosquitoes. So that means it is something that is so easy. Anybody can do it. Any control program can do it. Once you collect the mosquito, you can homogenize the mosquito and put the droplet onto the slide of the NS1 test kit, and it will show you whether the mosquito is positive. So that was the first thing that Singapore discovered. Of course, there were other countries who were using the sticky trap to collect the mosquitoes, which is a good, cheap method, but nobody went into using the NS1. They were trying, some of them did RT-PCR. Of course, RT-PCR is expensive, and people at ground level won't be able to do it. So we're really proud. So after working almost 3 years in Singapore, that was when University of Malaya called me. And since my hometown was here, my mom was growing old. So everybody said I should come back. And that's how I came and joined the university here. And then I got my professorship a few years later at the university. So I feel I have fulfilled my thing. And I had many students who have graduated working either on dengue, insecticide resistance, and also on malaria vectors of Malaysia. So I think currently I had 11 students who have graduated, all have found jobs. Some of them have gone to work in Singapore. And so I feel that as a researcher, it is good because you can make a name for yourself. Okay, you publish your work in good journals. You be very honest about the results that you get. And I think that you finally have a satisfying career at the end of your working life. That's how I look at it as being a researcher. Instead of being a program coordinator or someone who's working for a control program, I think the researchers and lecturers, of course, have got a better deal. That's my main take on it.
Absolutely. And this is something which we always say, that once a researcher, always a researcher. Doesn't matter at which part of the world you are, what disease, epidemiology, vector you are studying, the researcher inside you always brings you the questions which either are unnoticed or are understudied. As you mentioned about the simian malaria, when it was like a very big deal. So let's start with the first step, though. When you mentioned that at bachelor's, that was the
Yes.
time when you decided that you will pursue a PhD. Way back
Yeah.
then, when not many women were pursuing their dreams in education at first, and then pursuing PhDs, like taking it to the next level. And then, so
Yes.
we would like to know the story behind when you moved from India to New Zealand for your master's, and then from there to University Malaya for the PhD.
Yeah, because at that time I felt that doing bachelor's is not sufficient. You need to go a step further. So that's how I said that I must go and do my master's, because I was not very keen to just do a bachelor and be a teacher in a school. So I think that is where I decided that, yes, once you do your master's, that means you have got some background about how to do research, what you want to do further. So I think that was there because I was not sort of like so keen to do medicine. And I think it was my brother who was like sort of against girls doing medicine. I do not know why. He did medicine, but he was against like girls, women going into medicine. So he was sort of encouraging to go into science research, go into a PhD, then you can be a doctor. So that kind of a thing. So that is how I moved in. And as you say, when I graduated with my PhD, there were only 7 of us at the graduation ceremony. But nowadays they have about 500 to 600 people graduating one day just with a PhD. That's the difference between those days and the current day.
Yeah. So this brings us to our next question, that research in 1960s, as you mentioned, when we are doing the review of literature for our thesis, so we still, refer that fundamental research, which was done way back in 1950s, 60s, and then now in 2024, we believe that, as you mentioned also, that you feel that the research done at that time was ahead of their time, obviously, and sometimes we feel that we are limited with the technology, which they were not, and they started everything. Either it is the first in vitro culture of Plasmodium or anything like that, which we still cannot, find a cure for.
Yeah, I mean, what surprises me is that when a single case of actually the first time when the US people came down to Malaya was when they found a laboratory infection of Plasmodium cynomolgi. They were infecting Plasmodium cynomolgi mosquitoes, and they say that some of them were accidentally bitten and they came down with cynomolgi. And the monkey was actually sent from Singapore. So that is when they first came down to Malaya in 1960 to look for cases of cynomolgi. Of course, they did not find any cases among the humans because, I mean, at that time they were doing blood and trying to read the blood slugs. There was no PCR. There was no, there was no PCR at the time. So they didn't find any cases among humans, but they found a lot of parasites in the monkey. So they described all the different parasites that they got. So when this first case happened of Nolasa happened in 1965 in an American surveyor, fortunately he went back to US, and it was there that they saw that he was having fever. They found, yes, they saw the malaria parasite. They thought it was falciparum, and then they thought it was malaria. But you see, they had the inclination. They inoculated blood into the monkeys, into the rhesus macaques. And then they found that it was actually Nolacide. So in one case, again, when that one case was found, they again came down to Malaya. They went to the same area where this guy was located, and they sampled over 1,000 over people, but they still never found any. And again, they were just looking at blood slots. Okay. And they got mosquitoes, but they didn't find positive mosquito in that particular area. But they incriminated the vector in another area. Okay, they incriminated, and they said that that vector, Anopheles sacchari, can carry all the 5 simian malaria parasites among human primate malarias. So you see, for one case, they did so much work. And in 2004, when hundreds of cases were reported and published, the work was going on, but it was very slow. So why is it that? That's why I always feel that aren't we work, and we are fortunate now, of course, we have got PCR. Yes. So doing PCR, we can detect easily the various species, then the blood BFMP, because we did work on macaques. We caught a lot of macaques. We did BFMP. The BFMP shows, yes, it's positive for malaria parasite, but we cannot read it. So at that time, Bill Collins, who was working in the 60s, was still there in USA. He was still around. So when I spoke to him and I said, can you help my staff to help them to identify? He said, no, now we need to do PCR. They can no way read the malaria slugs anymore. So we had to, and 2004 14, when I went to USA, he had already passed off. So it was very sad that I didn't get to meet him because he did all the work on the vectors, laboratory infection those days. He did all that work in US at that time. And now we find that it is very difficult for us to do infection works in laboratory because we don't have the laboratory macaques. And nowadays it's like they are so protected, we can't easily touch them. So that's become that are things that is like a drawback to us.
Yes. At that time, it was so easy to do so many things, and which now, on the name of ethics and so many things, like which have a lot of constraints in our current research. So, ma'am, talking about the journey of your PhD, like you had done research in different capacity in different countries. So if you can tell our researchers based on your experience that what are the places or the research questions they should ask before deciding the continent they want to go to, because what has been seen that PhD students from India, they try to move out of India, and there are so many cases. So either it is for a short-term duration or for a long-term settlement, that what are the things they should keep in mind before making any decision?
I think the main thing is they must also understand that if they can go and help out in another country with the knowledge that they have, if they can help another country, maybe a poorer country, then it will be beneficial. It will be a win-win situation for both. You're helping the other country and you are also getting a name for yourself. You have done something for them. So it's a win-win situation. But if you are a new researcher moving out, then it will be best that if you can look at some of the other countries where you can do something more. Perhaps certain things are not available in your country.
Yeah.
Like I was fortunate that when I went to the Institute for Medical Research, when I was working on JE, we didn't have much knowledge about it. And I didn't know how to do RT-PCR at that time because we didn't even have the machine in our unit. And it was fortunate that the Japanese came in. We had a JICA fellowship, JICA grants. So under JICA grants, we went to Japan. I went to Japan. So there I learned how to do RT-PCR, how to do the various type of ELISAs, how to grow the virus. So those were things that I was exposed to. So when I come back, at least I can teach the people how to do it. So these are things that is important. You must be able to have that exposure when you are a young researcher. That's very, very important. You see? So, but you see, like in lecturers in the university, that's why university gives them sabbatical leave. Is to go and learn. So we were fortunate those days, even in a control program, at least WHO gave us a chance to go on a fellowship. So we see what is happening in US.
So, ma'am, based on your research experience, and also you did a lot of field work, which even when you did, there were not a lot of, infrastructure or logistic supports, which are now available. Still, what we see is like, whenever it comes to field work, the bias has been seen, it's like most of the researchers feel that, okay, it's if they have to send someone to the field, it should be a male. So taking this concept way back when you were doing your field work, how people were looking at women in STEM?
Quite fortunate in the sense that the Institute of Medical Research had a lot of female scientists who were researchers. So we were not that way. We were not like segregated and say, okay, you are a woman, you can't go to the field. We all went to the field. We were sort of like in equal numbers. Of course, the lower down staff were mainly all males. But as the scientists, as the researchers, we had both male and females.
That's
so we
great.
were lucky in that aspect. Yeah.
So if you see, like, because you have traveled so much all along, and you have been part of all these societies, committees. You have seen the number of researchers which happen to be female now is growing up, which is very good. And then this started the conversation of that people have to discuss women in STEM and the challenges they make. Either it is the logistics or the various other, things which should not limit based on the gender bias. So what are your experiences and how you have seen changing it over period of 3 or 4 decades?
I think that was something that I didn't face. Maybe I'm very fortunate. I didn't face that thing of saying that, oh, you are a female, so you cannot be going into that field. That was something that we never faced. And I think that if you look into the situation in Malaysia, actually there are quite a number of more researchers now who are women than men.
Nice. That's great.
That's what I feel.
No,
Yeah.
that is great. And in fact, this is something which we would like to tell to all the audience here, that if you're passionate about your research, nothing else matters. And if there are certain taboos in different part of worlds that needs to be broken, and Empowering Sense Foundation actually works with the concept of breaking the barriers, which happen to be one of this. And the thing now, when we go to the next question of the hardship of researchers, that when I'm sure like no research is just all the positive result, everything is working the way you want, either it is the hypothesis or the experiments, or if you're working in the field conditions that you think that you will do collections, but because of rain, because of so many other things, there are no collections. So those challenges, what you faced and what you can suggest to the researchers who are working in a similar field in the current situation.
Yeah, I mean, that was something that was very, very tough those days because when you go into the remote areas in where malaria was a serious problem, then it is that you need a four-wheel drive. So that was one fortunate thing, was that we had vehicles in the institute, four-wheel drives, and also we were lucky that during our time, most of the vehicles were already air conditioned. Our technologists used to tell us, because they have been working much before us, and they told us that those days when they go in, nothing, there was no air conditioning, it was very hot, the roads were so difficult. Sometimes they had to get down, push the vehicles. Yes, I have seen all those things. Sometimes our vehicles get stuck in the mud, and sometimes the drivers are new, so we feel we feel very scared sitting in the vehicle. But I'm glad that we had no incident. Everything, we overcame all those. But now it is much easier working on now that mainly all the human malaria has actually come down since 2018. We do not report um, indigenous cases of human malaria. It's only some of the introduced cases. But for non-Lasai malaria, it is the areas are not as deep as it was in those days. So they are much more accessible, and we are able to live. At least we can stay in a hotel and move to the site. But those days we used to stay inside the village, and it was not easy. We went through a lot of hardship. The guys have to cook the food for us. It's not that, you can go out and eat. They have to cook the food. So, of course, those are things that the current people working in Malaysia will not face. They will not experience that.
Speaking of hardships, ma'am, what was the most challenging part of your research over the period of time you were actively engaged in the field was?
See, even those days one thing was we did when we were working on malaria, we always dissected our mosquitoes. Okay, those days, of course, you can do ELISA, but we never did ELISA. So we used to dissect mosquitoes. We used to look for oocysts. We used to look for sporozoite. And then we report how many positive mosquitoes we got. Of course, now we can do PCR. So we still dissect mosquitoes. If it is positive, we bring it back in alcohol, and then we do PCR in the lab. So And in those days, what we were unfortunate is that all our microscope, we have to see where is the sunlight coming in and then adjust the microscope so that we dissect using the light from the sun. That kind with the light, with that mirror at the bottom. But this now, people are lucky. They take the generators to the field. They take good microscope, they plug on, and then they do their work. So those were challenges that we faced those days and now. You can see the difference.
Yes. So with all those challenges, how did you maintain a good so-called work-life balance and maintaining a good mental health?
I think it was not difficult. We used to spend about 10 to 12 days in the field, and then we come back. And then I suppose we were much younger and we moved. But I find that the current day researchers, even my PhD current day students, they will only like to be in the field from Monday to Friday. Then they want to come back. So I try to tell them that when you're going much further, to further places, they need to extend their stay. You can't see that, okay, my working day is Monday to Friday. No, we used to work even on Saturday, Sundays, we are in the field. We usually spend about at least 2 weeks in the field when we go. So sometimes you see, I had to run projects on JE and malaria. So there were like two projects back to back. So I'm practically away like 4 weeks in a month.
Oh, wow.
But it was okay. What the problem is that at least we had down support staff to help us, and we had the vehicles provided. So that was one good thing. But in the university, I find that those two things are lacking.
Yeah.
We don't have enough of vehicles to take, and we don't have enough of support staff to help the student, because some of the field research, you cannot do it individually.
Yes.
You need a support team.
So this is where the role of the support system comes. Either it is in research institute or in university or in any other settings. Now, with all this technology advancing, and then now people coming up with interdisciplinary research concepts, that people from astrophysics are now, working with biologists, with entomologists and whatnot. What you have seen, which you can suggest to our young generation or the next generation of biologists or entomologists, that how they should keep their ideas open and how they can build a more holistic approach research?
Yeah, but you see, like talking on malaria vectors, to find breeding sites were not easy. You have to go around looking where are the breeding sites of the mosquitoes and to look for it. But at least now they have the drone. So perhaps they can use the drone technology at least to help them map it out. And then you can go and see, okay, are the vectors there or not? And then you can take steps to see what control measures can be introduced in those areas. Because to go looking for vector breeding sites are not easy.
Yes.
Is it? And one thing is my team, I never got much involved with the larval breeding site because we never had time. We already spent about 10 to 14 days in the field because when we collect mosquitoes the next day morning, we are busy dissecting. Sometimes we dissect right up until 4 o'clock, 5 o'clock, and then we have to rush for collection.
Yeah. This is tough. And this is when researchers, like normally people say this for the medical doctors, that how they spend sleepless nights. And researchers did not get enough of acknowledgement, which ESF came up with the idea that every researcher on the globe should be celebrated. And that is part of the reason why we started this researcher celebrity conversation, that let's celebrate research. All those sleepless nights, all those hardworking hours in odd hours, days and nights spent in there. Yes, the publication is one of the things which is, fulfilling and content making you happy. For you, ma'am, what was the driving force which you kept going on and on and on in different countries over the decades? And with all those challenges, you never thought that you should give up on it?
No, I cannot say why I I mean, I suppose that I feel it for the people because, like, when we say we have eradicated malaria, we've eliminated malaria. When we get one death of malaria, I feel very sad because why should this person have died? Especially when simian malaria came into the picture, it's because, like, okay, in an urban area like Kuala Lumpur, it's malaria free. There's no vectors, there's nothing. But this person goes in hiking or shooting or camping in the forest, but he doesn't report. When he falls sick, he goes to the doctor. He also doesn't tell the doctor he's been out there. Perhaps he doesn't know. The doctor also doesn't question him. So he thinks it's what kind of fever, he's in urban Kuala Lumpur, what fever it is, he looks. And then finally, when he thinks of malaria, it is too late.
Yeah.
Nothing can be done. He died. So that is things that makes me feel very sad. So that is why I always feel that if there is non-human primate malaria happening in humans, I don't think that we should declare it as malaria-free country. Then everybody forgets that malaria exists.
Yeah. Absolutely.
So it's sad. But I'm wondering, very surprised how people who get infected, maybe when they go back in European countries, I think it's different because these people also tell them, oh, we have been to a tropical country. So I
Yes.
think they think it's malaria because I've read of many cases in the early days where people have contracted Plasmodium knowledsa. It has been discovered in US, it has been found in Germany, in Finland, Norway. So those countries, they are alert. So when people have gone, I think they know that malaria is there. So that's how they're able to detect and treat their cases. But here, unfortunately, they forget.
So, based on the experience and the expertise which you have with vectors, what will you suggest the new generation of entomologists who are trying towards the vector control in, like, obviously with different vectors for different diseases and infections, how they should build their research projects in a way that A, they get enough funding, B, they can collaborate and come out of those halos that a vector for, like, in case of Aedes, it's just a vector for almost all the viruses what you can think of. The mosquitoes can spread, either it is of a human or for animals or for what. So how they should build a what we say networking and come up with an interdisciplinary research proposal.
See, one thing that we have to understand now is that the taxonomists are a dying breed.
Yes.
So for the new generation of scientists, they cannot expect that every mosquito they want to do PCR to determine the vector. I think it's a lot of money is being spent on it. Yes, if it is a complex species, then you can do you can do PCR to determine the vector. But I think basic mosquitoes you should be able to identify. So taxonomy is one thing that I think if people working like for instance on mosquitoes or any other insect, I think they should like go back to basics and learn that first and then move. Don't think of everything. Don't think that you need to do molecular for everything. Then the amount of money being spent is also not there. And sometimes you may get false positives because now people are incriminating a vector just doing the PCR. So we do not know whether it is really a vector because like we dissect every other mosquito and we have not found the sporozoites, for instance. Whereas these people say, oh yeah, that is a vector. So that is something I feel the basic must never be done away with. Even though you have all the modern gadgets, all the modern techniques, I think you should still do it.
Absolutely. And as they always say in case of malaria, that slides are still the gold standard.
Yeah, their gold standard is there. At least you can look at it. But what surprises me was that those days they were able to like make smears and identify each one of those non-human primate malarias. The 5 of them, they were able to make slides and ID and draw pictures of them. But now they say, no, cannot. But it is. But yeah, it is very challenging. But I suppose that sense we are fortunate that we have PCR to help us. But I always feel even BFMP, okay, if you look at the parasite, you see that there's a parasite, you can't ID, then you can do PCR. So it is not necessary that you do PCR even when it's slightly negative. So it's
Yeah,
like negative, then
absolutely.
it's negative.
So
Yeah.
true. And this is for all the upcoming generation of entomologists that, as Professor Indra just mentioned, that basics can never be bypassed or overruled. Either it is taxonomy or it is the identification of a parasite. If you have a blood slide in front of you, yes, you can pursue PCRs on anything and everything with 99% negative results, and spending all the time resources for something which, if you would have got all the basics correct, might have been saved all of your resources, money, time, and the most important thing, your efforts into it, because you are putting efforts there. So
Yeah.
for next generation of entomologists, keep this in mind while preparing for real life, opportunities where you're going to help the societies for that. So, ma'am, one more thing which I would like to know your thoughts, that you have seen research evolving with limitations, as we have discussed a little bit. The researchers, their frame set mind, like now you have mentored so many masters and PhD students. The students, how should they keep their heads up with field experiments, with rejections of papers? Because that has been seen in India and around the world, that PhD students drop out after 3 years, 4 years of research, and sometimes even 5 years. In the sad and the worst cases, they commit suicide. So, what you can
Oh.
suggest to them? Yeah.
No, I mean, I think that see, one of the things that even when I wanted to do my master's, actually I wanted to work on some insecticides and insects. But my professor, Professor Salmon, he was the world-renowned taxonomist for Collembola. It's called microarthropod. I didn't even know Collembola existed when I went to work. And he insisted that I work on the taxonomy of the Collembolans. And he felt that it's a very safe project. That's the word that he used. You work on safe projects. So that always in my mind. So even when I went into when I joined the university, when I had students, I always make sure that I give them safe projects. Sometimes some lecturers give projects, but you do not know whether what's going to happen.
Yeah.
So if I think that something is difficult, it cannot be done, we're not going to get results easily, I would not give it as the main thing. Maybe it will be a small objective. If it succeeds, okay. If it doesn't succeed, it's okay. We can still do it without that objective. So I always make sure that the objectives that I give them are workable.
Absolutely. And I think this is the part
Yeah.
of mentoring and advising a PhD student, because in most of the cases, what has been seen, that these young enthusiastic students, they want to start their publications with science, nature, just in the
Oh,
first year of so in the first year of PhD. That's how I think most of the PhD starts, that okay, I want to publish in there. But the professor there, the
yeah.
mentor there, they know that okay, sure, we won't discourage you, but let's keep it more realistic. Do step by step, do all the experiments, compile the data, analyze, and then we will see where to go. And then by the end of 4 or 5 years, they are like, okay, I just want to get rid of it. Wherever I can publish, I'll publish and then move out of this. But what has been lost in some of the cases is that in not like in rare cases have been seen that people who were very passionate, very enthusiastic at the start of PhD, by the time they complete their PhD, they don't want to be in research anymore.
Oh, that is very sad. I think they must have gone through hell and heaven. That is why maybe they have just given up. You see, I think it all depends. Like sometimes, as I said, I think your project, the lecturers must make sure that they give them very viable projects. You know, you sometimes, yeah, you can do certain things. Like, for instance, when we were working on the malaria vectors, the simian malaria vectors, we do not know where the mosquitoes were resting. And we gave it as a project for a master's student in the sense that it is master's by coursework. So the project is just a small dissertation. It's not a big thesis. So when this girl came, she worked really hard. She had a nice, good back, and she did her sweeping of all the resting site. But you wouldn't believe she didn't get a single Anopheles mosquito. So I don't know what she wrote, but I suppose that she could have written all the other mosquitoes that she got and got away with it. But these are things that it is difficult if you will give this project to a master student who is doing it by research, as I
Yes.
said. So I mean, things I think, because even when I was working in the Institute for Medical Research, we had a diploma course, a diploma in applied parasitology and entomology. So the students who come for that course, they must have a degree. They must be actually already working in the field. They should be entomologists or parasitologists in their country. Then they come over. So we also give them projects to do. Right from the start, they work on their projects, plus they have coursework. And at the end of the day, they have to submit their small dissertation. So even for that, I always make sure that I give projects that are viable, that can be done. Because, for instance, there was this case of where this protozoa called Lambonella was actually found in Aedes albopictus way back in 1921. It was reported. So when the Americans were working in America, they found Lambonella clarki. Here in Malaysia, we have Lambonella stegomyia. So they found there, so they were very interested. They came and they asked us. So here though we have been examining a lot of Egypti, a lot of Aedes albopictus, it's surprising that we never find it in the larvae. You can actually see it moving. But I do not know how come we have missed it. So when they asked, and they showed and they talked to us, then I think in somewhere in Penang, up in the northern states, I think they managed to find it and they showed it to us. And so we said, okay. And the few days that they were with us, we didn't get it. So one of my colleagues said, why not I give it as a project for the diploma student? I didn't dare give it to it, but I did apply for funding to run that project. So we used to go. I used to send my technical staff. We go out. We used to collect. Finally, we found it. We found it in the rural areas where they were tapping rubber in the rubber estates. In those cups, the Aedes was breeding there. When we looked at it, we finally found it. But I do not know how we missed it at other times when we screened so many thousands of Aedes mosquito because we go for Aedes larval surveys. But how is it that we never looked at it? I do not know. So anyway, I published a paper, that was all, but we couldn't culture it. We tried to culture. They were able to culture Lambonella clarki in America, but Stegomyia, we were not able to culture it using their method. So we just gave up. But you see, that is an example like that. So if you're given that to a student, a project to a student, it's very, very, I call it very risky. So I wouldn't take.
Yes. So, ma'am, at the edge of the conversation, I would like to know the word of wisdom from you for next generation of researchers.
Okay, but I think what I feel is that always think ahead and try to move forward. Okay, of course, like now people are thinking of like genetically modified mosquitoes. Even me at my younger time, I also was thought of, yeah, genetically modified mosquitoes is so nice. We can modify them, we release them when left. But we don't think a bit further to see what is going to happen. After COVID came about, now I am very scared. So I will now, when I sit down and think, I said, when we release these mosquitoes, we do not know what is going to go on in the field, in the wild, what's going to happen. The mosquitoes have been there for ages. I don't think it's easy to get rid of them. As you know, Spillman said that they are the first ones to enter the water and the first ones to leave the water.
Okay, nice.
So I feel that, those working with mosquitoes or things, we have got to be careful
Nice.
what we want to do,
Okay.
how we want to do. But
It
it
was
is
good.
always good to be proactive, to think.
Yes.
Like you see, for Aedes, we found that this method of collecting the Aedes mosquito using sticky trap, using the NS1 to detect the virus, and we find that once you find a positive mosquito, a lag of 1 to 2 weeks, you're going to get cases coming up. So you can inform the people beforehand that a case is
Yes.
going to happen, so action can be taken. People, if they fall sick, they can go to hospital. So you are informing. This is something that is proactive. So
Yes.
people are alert. So this is what we need to think of, something that is proactive. I personally don't feel happy thinking that we can release something and they will do the job. I am not in for that now after the COVID outbreak. I'm
I
very
can.
scared about that.
Yeah, and I think most of the world will agree with you on this part, what we have all seen during the COVID pandemic. So I will tell to all the audience that, as ma'am said, that be proactive as a researcher, think ahead, and then always keep motivated because there will be a lot of challenges in there, but you have always keep your head above the water and then enjoy the research. So we'll say thank you very much, ma'am, for taking time out, sharing the journey, and inspiring the next generation of researchers.
Thank you so much for having me. Okay,
For all
bye.
the audience, we'll say that stay tuned for other celebrities episodes. And if you want to connect with Professor Indra, you can write it to her. You can see the passion she brings to this conversation, especially as a mentor, so that you can have viable, like set goals which can be achieved. Nothing like extraordinary out of the world for PhD students. And also, if you want to contact Empowering Science Foundation to be in touch with our other researcher celebrities, we are there to help you. All we need from you is your passion, research, and whatever support we can provide, we are there to do that. Thank you very much, ma'am.
Thank you.